Thank you so much, Max, for giving us the time and for joining us on the podcast.
It's great to be here. I'm really excited to see where this discussion goes.
Can we start with a bit of a background story? Can you tell us how did you end up here?
Oh boy, well, how did I end up here? How did I end up on data on the rocks? Let's see. Well, where do I start? I don't know if I want to give my whole life story. I guess education. I undergrad computer science, Yale. I did a few software engineering roles. Since then, I was kind of like a little underwhelmed about where my career was going, so I went to grad school, as people do, and I took information systems at NYU. There wasn't a data science thing yet, but I did it because it was like, it was half computer science, so I could learn more there, but it's also half at the business school. And when I was there, I got really into the idea of machine learning and Bayesian inference. I really fell in love with kind of and natural language processing. I really fell in love with the kind of statistical side of programming. I thought like that's where the real interesting stuff was. One of my professors there was Jan LeCun. He's very well known in machine learning, and he showed us some of these deep learning stuff before it was big, hipster style. And also at the same time, I was really into location data and maps. I had a side project called StickyMap.com, which I built, in those years, which was kind of like people, that was back when, Google Maps had just put out their API. People could like post little things over on the map. And I thought it was interesting. Unfortunately, it was like, I wish I was able to figure out, like, I didn't even think of getting funding or whatever. People told me I'd get funding, but I didn't know where to start. It could have been bigger than it was. But anyway, when I discovered Foursquare by Dennis Crowley and Naveen and a bunch of others, which was the first like iPhone app where you could check into places and share with friends where you are, I was like, wow, this fits exactly what I'm building. And it's really how this kind of software should be built, where we're building up a venue database over time. I was like really compelled with the use case with the game. I still use it today. And so they were looking for machine learning engineers. And, they're like, are you an expert in machine learning? And I'm like, yes. And even though...
Are you one of those 500?
500?
Back then.
What's 500? Well, I mean, no, I'd taken classes in it in grad school, but I was very excited to get started on it. And they needed server engineers as well, which is a lot of what I did, trying to make sure all the code works. So yeah, I got that role, and then I worked there for basically 10 years. That was, really 3 phases. The first phase was working on the consumer app recommendation system for venues, trying to figure out what's a real venue, what's not a real venue, building the ratings. So if you go on the Foursquare City Guide today, you'll see the ratings from 1 to 10. That's my algorithm. I don't think they update it too often, so it's degrading a little bit, but I'm kind of proud that after like 8 years, it still kind of holds up. Second phase of Foursquare was when they were an enterprise company. So basically, telling companies, whether their ads were driving people into their business. So that's a causality model there. And then the third section, I was working directly with the founder on labs, where we launched Marsbot and Marsbot Audio. And so that last version was, you can kind of walk around the city and we'd know immediately when you like walk past a storefront or something, and we could play a sound. And it was like, well, what could we do with this? And unfortunately, the company wasn't willing to kind of see that all the way through, and things were getting a little weird during COVID. So took a little time off, had started working on my personal project, newmap.ai, had some health issues to walk through, which we don't have to get into today, but I'm pretty sure one day on my podcast, which I haven't shared all the details about, I'm going to go through the whole story. But the good news is I'm good now. And now I'm back. I was living in New Hampshire at that time, because I was like, who wants to be in New York during COVID? And so, now I'm back in Connecticut. So those last few years have been a journey, but I've been through quite a lot. So that's a lot of threads to pull on. Probably don't want to pull on all of them, but I'll let you figure that out.
Awesome. I'm super curious about newmap.ai, but first, I want to ask you some nerdy questions about your adventure at Foursquare. 10 years.
Yes.
I
Hmm.
I can only imagine.
Yes.
First, in stage one, you mentioned you dug into the issue of what's a good listing and what's a fake listing, or what's a real listing and what's a fake listing, and
Right.
that's something that's super challenging to us today. And as far as I know, to basically any company that's trying to build a large list of entities, regardless of the methodology you use, regardless of how you do it, how you maintain it, it you have different flavors of the challenge. I want to understand more
Yeah.
of the challenge that you had and how you tackled it.
Right. So, I mean, that is, I mean, you're absolutely right, because that was a problem in stickymap.com when really it was just a few people posting things. That's still a problem for Foursquare today. They haven't solved it. They're still coming up with different versions of it. Um, so one of the things that I implemented, which may be a little different from like the main system there, was just trying to. So what Foursquare had was that they sort of had like a Wikipedia of venue databases. I mean, there's another Wikipedia version of that called Wikimapia too, which I don't know what happened to them. I don't know if they might be still around. But basically, people called super users would like anyone could suggest a change to the venue database. You just go in and suggest a change, you add a venue or whatever. But the super users were people who had expertise in their area. And in this case, it literally is, unlike Wikipedia, which is like an area of study, this is literally like an area of the world. And they sort of vote on whether these changes are correct or not. And our job was to sort of figure out, well, how many votes should it take to accept a venue as or even as something as a change of phone number or whatever as valid, as something that we want to show users. And so uh, with that, I kind of relied on a Bayesian solution. I would look, and there was a little bit of black magic here, because it wasn't quite clear at times. So you want to have like a ground truth. Like, I want to know, what are this person's false positives and what's this person's false negatives when they vote on something. So for example, it's not enough to say, oh, this person always finds the incorrect changes and they always mark them incorrect. But they could be someone who's marking everything as incorrect, so their vote has no signal. So you really want someone. So you really need to know both sides of it, and that's where Bayesian inference comes into play. You need to know, like, do you have more information than you had before given their vote, and how does that work? So it's a very simple kind of like a naive Bayesian model where I kind of assumed everyone is independent, which is not really true. But we tried to get their false positives and false negatives by placing some changes in their list, which I don't know, it may be a little frustrating for these users, but we placed some changes in there that are not real, but are like either changes that we know are false or changes that we know are true. Although, how do we know that something's really true? That's maybe something that's been there for a long time. But and then sort of measure how they did on that. So that worked okay. I mean, there was very little, unfortunately, like, it was hard to measure how that was working, but it was at least an objective way to kind of set up that system. Then on the other side, there's like, well, some venues are marked as spam. How do you, okay, if you mark some venues as spam, can you compare venues marked as spam to venues not marked as spam, and just shove that into, let's say, a very like a standard machine learning algorithm. Probably in this case, it would be some kind of like gradient boosted trees or random forest, because you have a lot of like, oh, who created it? When was it created? Where is it created? What zip code? What what is the what's the text look like? That kind of thing, And so so that's another way to try to find spam as well on the kind of the venue basis. So those are two answers to your question.
Uh, I'm guessing. So what you described is basically the root cause for why it's a major challenge for us today, and I think for everybody that is trying to build a large list of entities. Uh, you have nothing to compare it against, and always for new engineers joining our data team, it's a massive shock because all the statistical approaches, they require some golden data set, and then you work your way backwards from that. And when they learn that, as opposed to academia or like lower volume data sets, you need to sort of assume what's good and what's not, and based on that assumption, you make more assumptions. There's a period of a few weeks where they freak out.
Yeah. I mean, if I could give an example of, and this might be an out of a data example because the NLP tools might be so much better that you don't even need to do this. But if I could give an example at Foursquare where it did work, was when we were doing sentiment analysis on people's tips. Those were like 2 or 3 sentences they would leave at a venue. And it turns out those ended up being a really good signal for whether a place is good or not, because like and dislike, it's cheap to leave a like, and it's also cheap to spam it, because at least when someone spams with the tips, we're going to be like, well, that's gibberish, or take that. But then there's a question of, okay, how do we tell which tips are positive and which are negative? And the thing that for the existing models at the time, which are 2012, were not good enough. And for this type of data, now today they almost certainly would be. But the solution we came up with might still be a good way to go, which was we looked at people who both left tips and were liking and disliking the venue and leaving what we called an explicit rating. So you can say something negative and give the place a high rating, or say something positive and give the place a low rating. It's not against the law, but we kind of assume that overall that's going to be a pretty good data set of, here are things that are positive and here are things that are negative. And using that to train a sentiment analysis model on a bag of words ended up working really well. And not only did it work really well, but it worked in every language that we wanted. So that was cool. And that's a case where you had maybe not ground truth, but pretty good ground truth. And then, there were models like, things marked as spam. What do you compare it with? Things not marked as spam. That's not necessarily not spam, but it's okay. Oftentimes you want to get explicit positives and explicit negatives versus like explicit positives and then just the rest of them. But you could try to do that as well. But yeah, always a big challenge.
And once you mark the job done, you never know if it's fully done, and if it's not, to what extent it's not. So I was looking at some numbers. In the year 2022, Google Maps removed something like 20 million fake listings.
Wow.
Which sounds like a big number. Because it's still a problem today. But I'm sure that even for them, it's hard to say.
Yeah. 20 million out of how many?
Exactly. Yeah. And
I know. I know Foursquare tries to sell their venues database, and that was a big discussion where people are buying it. Well, how many of these are correct? And
absolutely.
Well, it was always fun. I remember. Well, I remember there was one meeting where the potential client was, your data is bad, but we want you to fix it, and then we want it. So you get stuff like that.
Yeah, and I think today, because definitely that's the number one question we get from clients, and we try to approach it mature and to answer it honestly. Yeah. Like, we will tell you what we do and how we measure it. But in reality, like, if you ask us, okay, but compared to like the real world, there's no way in which we can honestly answer that and give you like a mathematical.
Just to clarify, I haven't been at Foursquare for a while, but I think their venue database is pretty great. But it still is a challenge for clients, to take a look at it and parse through it. So, but anyway, yeah.
Okay, now I'd like to move to the second thing in your story that caught my attention. I worked in ad tech for a few years, and I know that attribution, what you mentioned as how do you know that Foursquare is actually driving traffic to your venue, which I imagine mean actual people that walk through the door.
Yeah, so a little bit of clarification on that. These were clients who they might be chains or travel destinations or something like that, and they would have their ads anywhere on the internet, but they got information back on who, like what
Wow.
IDs were seeing their ads, and they knew that we, for those same IDs, knew when those people were visiting their stores or their locations. So they wanted us to merge those data sets together, very expensive merge, and then build a causality model to figure out, okay, are the ads that I'm actually sending really causing people to go to my stores? Like, is it, am I sending it to some people who are never going to go anyway? Or am I sending it to people who are going to go anyway? Because, if I just sort of hand, like that's like to make an analogy in the physical world, if I'm standing outside of Walmart and I hand a pamphlet to people visit Walmart every time they go in, and I can't just take credit for that. They were already there in the parking lot, and so like they're like, okay, what is this actually bringing into me? What can I actually take credit for? And so that's kind of a difficult problem.
So I'll ask you a nasty question. How do you? Because I think one of the most complicated things in the process you're describing is how do you do entity resolution between the people and the devices, right? Because if you're showing ads across platforms, you need to know that this ad was first seen a week ago on Facebook, and then you're adding your layer of, I think this user wouldn't have come to visit you. This doesn't look like something that was on its way to happen. And then you capture that the user is on its way to the location, but then you actually capture the device, right?
Right. Yeah. So at the time, like there was device IDs that was kind of similar across everybody. I think there was some model that was used, before the data got to me. This is all a little creepy to some people, by the way. Like, I'm kind of, I don't know if I want to work on it anymore, but the data before it got to me was just like kind of merged, so it knew if you had multiple devices, all these IDs are the same person, and yeah. So by the time the data got to me, it was like, okay, we could assume that all this stuff is from the same person.
Got it. Okay. And you needed to see, for example, would you call it a conversion if the person went nearby the store, or do they have to actually get in? Or let's say the store is inside a mall, right? Call it a conversion.
So Foursquare actually had, walk-by events and they had stop events. But, for this, we were using stop events.
Okay, so it doesn't matter if the user went into the mall as long as they didn't visit that fast food chain.
Yeah, we're trying to see if they visited that exact fast food chain.
Very interesting.
Yeah, and Foursquare is pretty good with that. They it's surprising that they know that you were at this place and not the place next door. So,
which is incredibly hard.
Yeah. That was an interesting problem. Usually we look at people who have checked in at Foursquare and Swarm, who, I mean, I don't know how they do it now, but it was like, we add this data set of where people were when they pressed that check-in button. And so it was like, okay, we could do some kind of nearest neighbor to get a good idea. We use other things like what Wi-Fi signals can you see from that point? What, that sort of thing. So all those combined sort of made a pretty good model.
Yeah, it's probably much cleaner than to build it the other way around by first mapping the geo and then assuming that all the signals coming from the device.
Yeah. Correct. Yeah, because the signals coming from the device are correct. It's weird because they bounce off buildings and stuff in very strange ways. And so if you're comparing it to other signals that you've gotten at the same place, then it's a lot better than simply trying to look at that place on the map.
Yeah. And then you mentioned Marsbot, which I think I understood what it is. I want to use that to ask you a slightly different question, which is, in what way do you think people haven't really at scale figured out that location data in any form can be used, and that in your mind would make it for an interesting use case?
Well, I can talk about the two versions of Marsbots. There's one that we put out in 2016, and this is all A lot of this just comes from the mind of Dennis Crowley himself, the founder of Foursquare. He's really into this stuff, and I if he's listening, I really encourage him to continue his work in trying to make a new one. But anyways, the first version in 2016 was a text-based one, and basically it would know when you go into places, and so it would text you as you're out and about, and so it was sort of it was one of the best features was thing I put into it because it was based on my NLP work and my analysis of the Foursquare tips was that we know for every place in Foursquare, like what the best thing to order is, because we've done entity recognition and we've pulled from their menu. And so you combine this together and you know what people are saying positive things about. So
Sure.
Basically, and we know a little bit about the person's preferences as well. So whenever you go to someplace, it would text you, this is what you order. And that has been like a really great experience for me and a lot of other people when that app was around. That was really exciting. And then Marsbot Audio, which is the one that came out, we started work on it before COVID, and it came out during COVID in 2020, which sort of made it a little bit of a difficult launch. But the idea was you walk by a particular spot on the ground, we get that information. That's geofencing. That's something that is not that hard to do. I mean, Foursquare did have some of the data on where storefronts actually were, so that kind of helped us. But I don't think, we need Foursquare to really build this application. And the idea is we can play an MP3 file based on where you are, or we could do text to speech. And so we would do things like, just for fun, not because, this is a good product, but whenever you walk by a McDonald's in the city, it would play this little this bird chirping. And at some point I was like, well, what's that? I was like, oh yeah, put that in, And so we had people recording things and uploading them from their phone. It turns out regular people can't do audio. The iPhone is terrible at audio. You just hear and I'm just walking around hearing that. So that's not good. It's not even people are trying to purposefully put up bad stuff. So at some point I had comedians walk around the city and make comments on things. And I feel like that could have, that was funny. I had a really good experience with that a little bit. Some of their comments were a little too long because I think they were not really sure what the, how this thing is going to be used. And so I think a few more cycles of experimenting with that would be a lot of fun and would make the city easier to use. And really, augmented reality has been such a dream for a long time. And I'm still not sure about the Vision Pro, where you're just kind of you're not going to be walking with that out and about. That was the dream for the Google Glass was the idea that you're going to be walking around cities and towns and whatever. And also I think some of this applies to small towns as well. Now that I've lived in New Hampshire for a couple of years, where, you can get information on different spots, but I hope that I hope that more applications come up with that in the future. I mean, some of them are going to be art projects, some of them are just going to be plain old tours, but maybe there's something a little more functional in there, or a little more contemporary, kind of listening to the radio. Okay, you're listening to a radio station based on where you're standing, or a live feed. I don't know. So there's a bit that you can do with that that still needs to be explored. What audio feed is good for people.
I agree, and the most interesting thing I think it's the timing of it. And today everything's ready for exactly what you're describing. I get 7 billion different experiences based on who the person is and where they're at and what the moment is and everything. Everything in the supply chain of technology and different components needed is there. I think the user experience is extremely hard to nail.
Yeah. And that's why you really have to launch something, at least to a group of test users, and just have it try things again and again and again, which, someone's got to invest in that. So
For sure, and it's a handful of people that can usually, if they want to do it at scale, because you need all that data, right? Foursquare was
right.
building upon a lot of years of uh, technology in that space.
Mm-hmm.
I had interest in very early. I think I was just out of college in my first product role. We had a project that is somewhat similar. It was at a much smaller scale, and we did it in partnership with a large infrastructure provider that was basically providing most of the Wi-Fi connections in a few cities. And the whole or the POC of it was, if you're in a park nearby and there's a promotion at your favorite food at a restaurant really close to it, we'll just let you know as long as it's for dinner when it's 6 p.m. or 5 p.m. and it's at the right moment and it's for the right person. Unfortunately, as I'm sure you can predict, everybody found it spammy, in despite our efforts to make it really, really situational, and we were actually trying to provide more value for the user than the advertiser, who the advertiser wasn't even paying for it.
Right, right. I think, it's one of the great things about Foursquare was being able to build things like, oh, this is how it should be built and how it brings value to us. Now, that ran afoul of like business demands, which is why the Foursquare today looks nothing like what it did. But that's the trick, is try to bring those together, and also having it not be spammy is tough, even if you're just trying to provide information. Like our test apps, we often want it to be noisier than we would otherwise want it to be on the actual marketplace because we want to test it more. So there's a lot to think about in terms of that. So I don't know. There's usually, like, if you want people to test it, you could have noisy mode, not noisy mode, all of that. When we were testing Marsbot audio, it was like, let's just be as noisy as possible because I want to hear everything we could possibly say.
So I think, Max, you're one of the few privileged that got to work on this kind of stuff very early, way before it was sexy and way before you had the opportunity to manipulate a lot of data in a large number of companies. And I think you were lucky enough to get the taste for it very early in your career, in a career that I imagine back then wasn't interesting or sexy to any 21-year-old. The prospect of it until you actually get to do it.
Foursquare was very exciting in
Right.
2011, 2012. So I wouldn't say that. I would just say, look, anything that you work on today, almost anything in tech, like in a few years, you'll be thinking, oh wow, I was very early. It never feels early at the time. It always feels like, oh my God, Foursquare is the latest in a series of social media web 2.0 apps, another social network. So everything feels late, when you get to it. But then a bunch of years later, it feels early.
Yeah, but I mean, all the challenges along the way, from polygons in space, attribution, they became much more common and applied to a lot more things, because you were part of that select group that actually built the first iteration of these solutions.
Yeah, I mean, I can point out there were many who came before us, but yeah, I don't know how the numbers break down.
To me, I'm curious what that taught you, and what made you start building NewMap AI, and what did you think is broken, or what's way too cumbersome, and you're trying to tackle it.
Right. So with NewMap.ai, I think, because I'm working on it as a personal project, and maybe this is part of the problems with the project, as well as the as well as the opportunities of the project, is one of the things that frustrates me about working in software is it's always like, get something working now. I don't care if it's not the most elegant solution. Just get it working, because we got to get things to the marketplace, and that's usually the right way to go. But it's like, well, wait a minute. What if I think about, how should this work? How should data work? How should databases work? And then kind of always think about the long term. And I don't have business needs breathing down my neck, what comes out of that? Well, I can tell you what could come out of it, which has come out so far, me working on a side project for years and not much coming out of it. But I feel like there is going to be, if you have a project on the back burner like that, that's where you have opportunities for really big paradigm shifts and really big changes in the way we think about how to do things. It's almost like kind of a university project or something like that. Not all of them, but it's always worth taking your shot at that. And so for newmap.ai, this is like, okay, well, data is incredibly messy. People always screw up when they're migrating databases or hooking into APIs and things like that. Things get out of date. They're so hard to maintain. It takes up so much of your time. Given all of the problems that I've witnessed during my career that I've struggled with, and even not just like big problems in terms of trying to prevent errors and stuff, but or trying to prevent bugs, but also big problems in terms of like why is working with data so frustrating? Why does it take me so long to understand the database? Why can't I just get up and running as quickly as I sometimes can? And it's like, okay, what's the solution that I would build? What would I like to be working with? What would I like the future generations to be working with? And so that's what I'm trying to do with newmap.ai. So the idea is that it is I wouldn't say a decentralized database. It's a series of centralized databases that can communicate with each other and can communicate internally, that's based on type theory. So instead of most databases today that you work with, a relational database or a key value store, they're not going to be so heavy on types. It's going to be a little like JavaScript, which is like loosey-goosey on the types. It's not going to be like Haskell or like Scala, which I'm used to using at Foursquare. And I really like working with a strongly typed language. I feel like it prevents so many bugs and makes me so much more productive. And it's like, well, if we could bring these to a database, we could not only figure out how to, and then also include strong versioning in the database. So, a lot of, you could do this now with relational databases where they have versioning on the schema. So you could tell when something's coming in. But if you combine that with strong typing, and then you could have databases be a very simple multiplayer game where I can make reference to other people's data and other objects. And I'm trying to come up with some good examples here. I have some very simple examples, but it's just let me come up with a data model that's clear, where if I'm working with I could just start working on newmap.ai. My vision is with any application, I'll just gather data on newmap.ai. But as I'm using newmap.ai, all of a sudden I'll get recommendations for, this data set that you have here looks very similar to what someone else is working on. And look, they have a bunch of functions and models already set up for you. You can kind of import that. So you get a whole bunch of power from the network immediately. And so it combines the statistical part of AI, which is machine learning, with the abstract mathematics part of AI based on category theory. I think putting those together would be really smart software. So I know that is very wishy-washy. Right now, you could actually go onto newmap.ai and download it if you want. It shouldn't take you too long to set, if you set up SBT, which is the Scala, Scala environment. You could actually use some of the language, which is based on Scala. I'm open to changing the language so it looks different from Scala, but it's just, you can get an idea of how to build objects, how they grow over time, how people keep track of them. And so hopefully over time we'll have something good to show off. I mean, something very simple an object that starts at a base state, whether it's an empty table or a counter, and then users can come in and give it commands. So if it's a counter, the only command you could give it is increment, and just try to build something where a bunch of people maintain counters and can read each other's counters. That's the very simple prototype that I want to build, so that hopefully we can get this out there, because I've done a year of work and research on the full system in terms of like the the category theory and the type theory, which a lot of that was like mind bending.
So let me know if I understood correctly. Um, Definitely, you touched upon a number of challenges that we see every day in our team. Uh, I think transportation of data between different systems, and I don't know, I
Right,
mean the database, but different systems uh, always produces a lot of bugs, and some don't
right,
even happen immediately.
right. I mean, let's suppose you have an ID and then you have a different ID, but they're both numbers. And so, but one corresponds to the other. Well, how should that be solved? And if it's kind of solved willy nilly, where you're just like, all right, well, maybe I'll call this conversion function when I think I need to. At some point, someone's going to forget to call the conversion function, and
Yeah.
all hell will break loose. But if you say, okay, I require this ID and I require the type of it, then it's like,
Yeah.
okay, oh, you gave me the old ID, no problem. I have this function right here that automatically converts it to the new ID. You don't even have to remember to call it. Fine, I'm good. So something that works a little more seamlessly like that.
Yeah, that definitely uh, is a challenge very close to home. So, for example, you can imagine in our data processing pipelines, we go from a product name and a product description that we then associate with a company. It goes through a number of classification models and
Right,
then a statistical aggregation uh, to sort of mitigate the inaccuracies and false positives and so on by from the classifiers. And that is what we defined initially as the challenge of this task. It turns out that there's another more important component for clients that comes afterwards. Everybody uses a different taxonomy for classifying products. So your list of 10,000 codes might be very different than my list from 10,000 codes. And unfortunately for us, maybe even the list of 10,000 classes that we've put into a model and that we now have to redo.
right.
So, and we have a bunch of technology, actually a lot of effort gone into just this very basic transformation to make sure it's correct, and we cover, as you can imagine, it's not just changing one code to the other, but taking into consideration a lot more information because the taxonomies aren't just a different in a difference in label.
Right. And the question is, okay, if I have some conversion, then I can run everything. But if and maybe I could try multiple conversions, but you really want to organize that really well.
And make sure you keep track of it at any point, and
Yeah, and that it's impossible to screw it up. You want to set it up so you're not going to give the wrong conversion or the wrong thing.
yeah, and
And
I think
and if I have let's say I have a new taxonomy for you, and then I have a conversion function from my taxonomy to your taxonomy,
yeah,
it'd be great. But let's say I'm continually updating that because I learn new things, I'm making new stuff. You want to be able to automatically, get those updates and know that everything is going to be fine on your end. So
that actually, Max, happens all the time.
yeah,
And
yeah.
for us, it's a
That's why I'm building this thing.
yeah, that definitely. So it's for us, it's a heavy effort and a linear effort with every change that you make as a client in just maintaining a two different taxonomies or making changes to your taxonomy that might be a custom version of the taxonomy that everybody else uses.
Yeah. So yeah, hopefully I can get some sample software out and it's not vaporware in a little bit. But I'd love to have you give it a try. Maybe try running a node.
I love it.
Whatever. Hopefully I'll make it simple.
We use Scala a lot, so definitely not a problem there.
Sweet.
And if you get the chance to get to this, the second biggest stupid challenge that we have, and I think everybody has, is dealing with unique identifiers, unique identifiers.
Yeah.
Which is something, or merging data in general, happens for every client that we work with, happens for us. If you get to build graphs, then different nodes will have different IDs, and you have to maintain IDs for the connection between two different IDs, and it gets very, very messy very quick.
Mm-hmm.
Yeah.
Yeah,
And
I hear you.
years of hard work down the drain.
Well, I hope not, but it could be years of hard work that you feel like, oh, I should have been able to do that quicker. I feel like that's the life of a software engineer. You're always like, I should have done that quicker. It's kind of like playing golf. I experienced that. I don't play golf very much, but my experience is when I play golf is if I didn't get it in the hole, I'm disappointed, even if it was a really good shot. It's like same with software engineer, like, I could have done that quicker. I could have.
Yeah, you always have what you think the task or the feature has to be, and then you have the 2 weeks in which you deal with other things until you get to that.
Right.
I wanted to ask you about something that that I found very interesting. I watched a few of your podcasts and interviews.
Look, maximum. How did I not talk about my podcast? I'm a podcaster. I'm supposed to talk about my podcast all the time. We're already, an hour in here? I haven't gotten to it yet. All right. Yes, the local maximum. Sorry, go ahead.
No problem. And I actually loved what I think it's a perspective that's not often enough taken, and that you have it a lot. You actually prefer to use a lot more often statistical concepts than to jump into building like full-fledged neural networks, and be in a way tricked by the latest trendy technology. And that's something that I respect a lot, because we do as well, and we don't do it because it's a philosophical choice. It's because we've tried a lot, and usually to build a complex system you need to pair both. But I'm curious how you got to this perspective, and why is that?
I think I probably got to this perspective by being a fan of Bayesian inference and sort of building the math up from the bottom up, and noticing how fast you could get answers to some of these questions, and the fact that I could like wrap my head around it. Like, some of these larger statistical models, you don't really know exactly what it's doing, which is fine. If you have like a problem where you're like, okay, I have a supervised machine learning problem. I have a bunch of X's and I want to learn the label Y from these X's. It's like, and I have some way of measuring, how well I'm doing. Fine, put it into a supervised learning algorithm and get as sophisticated as you want. You know how well it's doing. But I think for a lot of other data coming in, you don't necessarily want to do that. You want to organize your data properly. You want to understand, very simple things like, are these integers? Are these positive integers? Is this count data? Is this, is this going to be always maybe a real number, but a positive number or a negative number? Do I expect this to have a fat tail or a thin tail? Are there going to be big errors or small errors? Some of these basic questions are very important. And then I think one question that is sort of the, before I took Jan LeCun's class at NYU, I took a data mining class with Foster Provost at the business school at Stern there. And this problem was a kind of a toy problem that I invented in my head when I was there, but it really gets to the bottom of why you need Bayesian inference and why machine learning doesn't have a clear-cut answer. And it's like, okay, if I have an ice cream store, let's just to simplify, let's say I have chocolate, vanilla, strawberry, I can get lots of people coming in that store, and I know the ratios of what people are going to want, so I can kind of plan for that, right? If I open up a second store, is it going to be the same ratio, or is it going to be completely different? And I have no idea. And that's not a question you could answer in the context of that problem. It's like, how well do analogies move over? And that's where you need like Bayesian hierarchical models and things like that. The Dirichlet multinomial model works in that problem. So I've done a lot of work on that. If you look at my papers, I wrote a lot about how to find the optimal Dirichlet model. Yeah, but the code is really easy to use. Definitely, like the Python code, like it runs like that. You could just, uh, so um, so I really think just thinking about these toy problems kind of help us understand why data is difficult and just
Yeah,
understand the values that we're working with. And also sometimes you could find really neat shortcuts, which is sort of nice.
absolutely. It, why build a complex solution when it could be
Yeah,
very simple?
yeah,
For us, the switch was made when we realized that certain components, if you're to use large language models or large classifiers or huge multilingual models um, that are or can be a bit erratic sometimes, and to be able to measure that, sometimes you need a very robust system even to measure it. And at some point, we realized that in order to use these very potent at their best, very weird at their worst type of technologies, you also need to wrap it around a very clean, clear statistical component that allows you to control the parameters and build like scores that are actually deterministic and that you control all the aspects at which you're looking,
yeah.
and you need to pair them both.
If you have more control over the model, you don't have as many problems with that. Like, if my
100%.
Dirichlet multi-gnomil code or my mixture models, like they just work. You don't have to worry about. I find even sometimes even very simple statistical packages don't give me the results I expect, and it's often very frustrating when you have to go in and
Yeah,
try to look and figure out what's going on. And so I don't know. That's one weird thing about working with data science, that it's like, isn't like, okay, I'm doing logistic regression in this new framework. I'm going to add an L1 regularization term. How come my parameters are not going to zero? What's happening here? Like, I implemented myself, my parameters go to zero, but why is it not in yours? In like, I was using like TensorFlow for JavaScript the other day. Why not? I don't know. Is it not doing my
nobody knows.
yeah? I'm like, I could draw, thing about the Lagrange multipliers, all that. I know what it was supposed to do. Why is it not doing that? Uh, yeah, it's so frustrating.
Definitely. And at the end, at the other end of the spectrum, a bit of a funny anecdote, especially when you think about all the weird quirks of data science in general. The paradox is that probably every engineer in the next 10 years will have to at least touch data science. So it's coming for all of us. Um, and at the other end of the spectrum, in the post GPT world, I want to end by asking you some a very generic question around what's happening and how you look at it.
Okay.
And I remember I looked at a piece of content um, on your website. Please say the website again.
Localmaxradio.com. And if you go to localmaxradio.com/archive, you'll get all of my previous episodes listed, which is now fixed. There was a bunch of current problems. You might have to, I might have to like update some of the links, but you could kind of see them listed out. But also, I set it up by number. So I think the one that you're talking about is artificial consciousness controversy. Is that the one you wanted to bring up? Because
Absolutely, which is a bit unfair.
right. So that's episode 213. So what you do is you go to
Yeah,
localmaxradio.com/213 and you get there as well. So sorry, go ahead.
no worries. Which is a bit unfair because I want to bring it up now, where so a year after you've posted it, uh, and in the meantime, so much has changed.
Yeah.
But I actually found your perspective, which if I'm to summarize it, really
Yeah.
probably not do justice to the complexity.
Remind me of what I said.
Well, I think the simple way to put it is, I think you made a very interesting point, saying that AI today, and I think us in general, humanity understands what learning is, how to mimic it, how to put it in AI. We understand what understanding is, how to mimic it, how to put it in AI, but that's still a huge gap between understanding and learning and what we need to call consciousness. And
Right.
I'm curious if a year later, your thoughts on it have changed after
Yeah.
seeing GPT-4.
No, my thoughts on it has not changed because it's not based on how good the system is. It's just based on the fact that, okay, what is intelligent? There's a bunch of definitions of intelligence, but like, okay, you're not just good at solving one problem. You're good at solving many different problems. You're good at generalizing. The more you can generalize, maybe the more intelligent you are. Maybe there's a lot of different kinds of intelligence, in the world, in the universe. There are like animals that could do things that we could never figure out how to do. And maybe there's a connection between the data part of intelligence and the physical part of intelligence, just learning how to, grab something or something like that. But anyway, we have some clues as to what intelligence is. In terms of understanding something means, I think, knowing like the relationship between things, what causes what, and the sort of what we kind of platonically call the mathematical relations, like A is a B or A is a member of B or whatever, but sort of mapping that onto the physical world, and just having kind of an understanding of how the concepts that we use relate to each other. Because if you're talking about all these concepts and you're just kind of predicting words and you don't understand how these concepts actually relate to each other, then you don't understand. But we can combine the ChatGPT sort of thing with a taxonomy in the background, and I'm pretty sure ChatGPT is probably building something like a taxonomy through its neural network architecture that's creating some sense of understanding. Okay, fine. Consciousness to me is a lot more about the subjective experience. Like, I am currently experienced being myself. I can currently see me and you on this screen through, and I can hear your voice. I can hear my voice. I can see that we're recording. I am seeing colors. I am hearing things. Our senses and the fact that we experience life over time. I don't see any evidence that machines are doing that. I don't see any reason why connecting these neural nets together and making them more sophisticated would cause a machine to do that. We don't have a very good explanation for how our bodies and minds are leading to consciousness and subjective experience, other than, something that comes out when you have all the sophisticated natural stuff, occurring together. I don't really understand the mechanism of that, like we all, so I feel like we still don't understand the mechanism of that. So to say the machine is slightly conscious, which I believe was the tweet that that at the time kicked up a storm, and at the time I was responding to, is we have no good framework for answering this question.
What if we're able to add a component to exactly what you've seen from LLMs, to the decisioning engine? What if we're to add a really good complex memory function? So
I don't know if that changes anything. We might be able to relate to it just as we do another intelligent human being, or or something like that. But does that prove consciousness? I don't know. And like, how do you prove consciousness? There are people say, well, I know I'm conscious, but I don't know anyone else is conscious. I'm pretty sure that everyone else is conscious just by analogy. Like, I assume I'm a human being. I assume other human beings experience the world not exactly the same way, but in somewhere in the ballpark. But, we don't really have any clues as to the mechanism for that. And without any clues to the mechanism for that, I'm not really, I don't, not only am I not willing to say much about it, I don't think, I'm skeptical of anyone else who says something about it, unless they tell me what, where consciousness comes from.
So what you really need to see is some AI getting pissed off in traffic.
No, none of it. Like, it's like, well, would any behavior change my mind? That's a good question. I'm not so sure. I think we need to understand what causes people to experience things. And I haven't seen a very good explanation in science for that. Maybe I'm wrong. Maybe there is something a little better than what I'm thinking, but I haven't heard anything to my satisfaction. But then again, you could ignore this question completely, And if you focus on intelligence and understanding and combining the statistical side of AI with the mathematical side of AI, you come up with incredibly intelligent software. You can come up with, unbelievable tools for the benefit of humanity, which of course are always double-edged swords, but that could really move science forward, that could move mathematics forward, that can make us all more productive, make us all wealthier. Like all that thing could be done. So this question, how important is this question? Well, I guess it's important, in philosophical ways, but it could also be important in legal ways when people come up with ideas of like, okay, what are some laws and stuff we're going to try to pass around this, or what are some kind of like, what are the guardrails that we should make with this technology? And maybe it does have sort of something to do with that. I mean, is there a question of, can you torture an AI? Is that possible? Like, we don't know. Do they experience pain?
I think we're all doing that.
No, yeah, I don't know. There's no evidence of it.
We're definitely gonna live some very interesting times.
Absolutely.
Thank you so much. This was a pleasure. I hope it was interesting to you. Please, once again, tell the people where to find them, and if they want to hear or learn more from you, what to do.
Absolutely. So the first thing you could do is subscribe to my podcast. That's called The Local Maximum. You can go wherever you're listening to this podcast, your podcast app, just type in The Local Maximum and you'll find me. I talk about current events, machine learning, the technology. Sometimes I talk about like other things like, mathematics or politics, or I just did a few episodes on like how I would change the Constitution because I just woke up one day and wrote an amendment, and things like that. And then if you're interested in what we talked about and if you want to go to the website, it's localmaxradio.com. If you want to see other things I'm working about on localmaxradio.com/labs, and newmap.ai if you want to see that project. Very early stage on that. Yeah, there you go.
Thank you so much.
All right. Thanks a lot.